standing waves, music, the Rubens Tube, and spot the gorilla. Not this Rubens. This Rubens. First, how are standing waves made? I'm going to wiggle the end of the chain, and the pulse travels along, and nothing else happens because there's no end to cause a reflection. What I'm going to do now is to change the end to a fixed end, and this means that reflections will occur. If I wiggle the wrench again, what will happen now is that the pulse will be reflected. Notice that a positive pulse is reflected as a negative pulse, and also the amplitude decreases because of damping. I'm now going to try to set up a standing wave by wiggling the wrench at the right frequency. This is very difficult to do, and if done correctly, there should be places where the chain doesn't move or doesn't move very much. Now I'm going to drive the loop at exactly the right frequency so that it produces exactly one loop. Watch what happens. Notice the amplitude rises very, very quickly. You can achieve exactly the same effect by using a rope, or if you have one, a slinky. Now I'm driving the chain at exactly twice the frequency, and watch what happens. Notice that very quickly a large oscillation is produced where the point in the middle, this green dot, hardly moves at all. Now I've increased the frequency again and should get 3 loops. The places where the wave hardly moves at all are called nodes. Here there's one where this green ball is and another where this green ball is.
Standing waves in a Rubens tube. One loop.
Indicate the antinodes, places of maximum vibration. The ends, the nodes, where there's no vibration. And you can see why some teachers talk about bananas. Have you spotted the gorilla yet? Here's the theory. Each loop is half a wavelength long. Those must fit into the total length L. So the theory can show you that if we plot a graph, then we can find the velocity or speed of sound from the gradient. Here's the data from our tube, here's the graph, and it shows the speed of sound is 447 meters per second. No, it's not wrong. Our tube doesn't contain air, it contains methane. The speed of sound is higher in lighter gases, and theory shows that it should be a speed of 454 meters per second. Our value of 447 meters per second is very close and shows our theory is correct.